In this example, we're going to look at strategies for graphing a logarithm function on ALEKS, and this logarithm function has a transformation in it. ALEKS requires you to plot at least 2 points for any graph, and so that's a little different from the strategies that we discussed in class for graphing these. So let's look at this example here. We have to graph the function g of x is equal to log base 3 of x minus 3. Well, for this graph, the common function would be log base 3 of x. So we want to first concentrate on what does that graph look like, what are its characteristics. So a logarithm is going to have a vertical asymptote at x equals 0, and its intercept is 1 to the right of that. And what we've done in class is we've just graphed the logarithm using that information. What we want to do on ALEKS though is plot one more point. Now the easiest point to plot is where you take your logarithm and you let x equal the base. Alright, so for this one, since it's log base 3 of x, I'm going to let x equal 3. The reason why that's so easy to do is because it's easy to calculate. Log base 3 of 3 is equal to 1. So what you get is you get an ordered pair where your x-coordinate is equal to the base of the logarithm and the y-coordinate is always going to be a 1. And that gives you a second point that you can graph to get the logarithm. For instance, if you have log base 5 of x, then you would let x equal 5 and your y would be 1, and you would plot that point. So it's a very easy thing to do. So now that you know these 2 points, you're going to shift the graph. So if I have log base 3 of x minus 3 in parentheses, that is going to shift the graph right 3 units. So the first thing I would want to do on ALEKS is graph that asymptote. It's going to go right 3, so it lands at x equals 3. And then my intercept is 1 to the right, so I would plot that point. And then if you go back up here and look at the original that we graphed, you'll see that we went right 2 up 1 to get that position. Alright, so then I take this point and I go right 2 spaces up 1, and I'm going to plot that second point. So now let's go back to ALEKS and see how to graph that. So go to ALEKS, and I know that my graph that I want to do is a logarithm. This other one here is actually the exponential graph. We want to do a logarithmic function, so you have to get the vertical asymptote here. So you sketch or get that there and ask you to plot the asymptote first. We said it was at x equals 3. We place a point 1 to the right of it, so I click here, and then I go right 2 up 1 to graph that second point. So that's how we would graph that logarithm. Now its domain is going to be from the asymptote to the right. So my x value starts at the asymptote, which is 3. And you want to grab the interval that has parentheses on it because the asymptote's an undefined number. So we're going to go 3 to positive infinity, and my range goes up and down forever. So my range also is the interval that has parentheses on both ends, and it's negative infinity to positive infinity.